Hello and welcome to this episode of Weekly Bytes, where we take a tech topic and break it down for you in under 10 minutes. Have you ever seen Linux file permissions? They look a little bit like this. If that's always looked a little bit confusing to you, you're in the right place, because we're covering that today, and we're covering a few things about it. Number 1, why file permissions even matter. Number 2, the different types of owners of files and directories. Number 3, the different types of permissions. Number 4, decoding this weird looking permission string here. Number 5, numerical octal permissions. What that even means and the maths behind all of these permissions. Number 6, changing the permissions. And number 7, changing the owners. Whew, that's a lot to cover. So let's get cracking. You have my permission to view this one. So why do Linux file permissions even matter? Well, Linux is a multi-user system. Imagine a big house where everyone has their own room. Now you wouldn't just want somebody coming into your room and touching all of your stuff. These file permissions make sure the right people can read, write, and execute files. For instance, you wouldn't want somebody going into the king's room, aka root, and deleting the crown jewels. The whole file system. Let's bust out our trusty terminal here and start investigating these file permissions. I'm going to list out what's in our directory here. Now you'll notice that we have 3 instances of the letter R here, and that's because we have 3 columns for the 3 different owners. First one is the user, this guy over here. The second is the group, this one over here. And the third is other or anonymous users. Which brings us to our next point, the 3 permissions. R, W, and X, which stands for read, write, and execute. So how do we read this whole permission string? Well, this first portion here is a dash if this is a file. If it's a directory, it's the letter D. Second, we read all of the permissions. So this user only has permission to read. If it had write and execute, these 2 would be write and execute. The group also only has permissions to read. It doesn't have the other 2 permissions. And the same is true for other. So that brings us to our next point, octal permissions. Each one of these permissions is represented by a number. The letter R is represented by the number 4. The letter W, or write, is represented by the number 2. X is represented by the number 1. So what does that mean? Well, if we jump ahead to our next point and we start thinking about changing permissions, we can use a command like chmod and octal permissions to change the permissions. So for file 1, we have a permission of 444. 4 for user, 4 for group, and 4 for other. Read, read, read. But if I made that 544, the expected result would be that we would have read and execute, because execute is the number 1 and read is the number 4. So 4 plus 1 is 5. And if we observe the result, we'll see that we do in fact have read and execute. Now, if I change that to 6, that would be 4 plus 2, 4 for read and 2 for write, and that would make it read, write permissions. And if I made that the number 7, that would be 4 plus 2 plus 1, and those would be all 3 permissions. 4 plus 2 plus 1. And you can chop and change these around and do the quick maths to kind of combine these and execute octal permissions. And now you understand what the numbers mean. So let's play around with chmod a little bit more. We can use the octal permissions to give permissions to different users, So we've done this for one user, but we can do it for multiple as well. What if we wanted to give 777 and give all the permissions? We could also change that to be 764 and do combinations of this. We can also change this up to use symbolic permissions. For instance, we can use the 3 owners and specify the permissions we want to give and take away. For instance, if I wanted to take away the execute permission from the user owner, I would say user -x on file 1. And we observe that the execute permission is now taken away. If I wanted to take away from group the write permission, it would be g-w. And we'll observe that it's actually taken away the write permission. If I wanted to give some things back, I could use plus. So I could say g plus w, and that would give the group the permission back. You can also use the equals symbol to just say you only want a specific owner to have a specific permission. For instance, if I want the user to only have read, I could say u equals r. And now it only has read permission. And you can combine all of these by using a comma to separate all of the different owners and give them permissions. If I execute that, you'll see that it has changed the relative permissions. So another thing we can do is change the ownership of a file. As I mentioned before, this is the user and the group, but it's the user and the group that own this file. So we can also use the chown command to change the ownership of a file. For instance, if I wanted to change the ownership of file 1 to root, I could do that using this command. And we've observed that the new owner of this file is now root. I can do the same thing with chgrp to change the group of this user. Let's also change that to the root user. You can also change both of these using the chown command by separating them with a semicolon. If we wanted to change that back to our crispy user. That's a wrap and the end of this weekly Bytes. It sounded like we had a lot to cover there, but I always keep my promise of keeping these videos under 10 minutes. So if you found value in that, you can support the channel by liking and subscribing and also showing your love in the comments. And in the meantime, if you're looking for some more of my content, you'll find that over here.